Welcome everyone to CS Integration in Elementary. This presentation is led by me from Code Savvy and Katie Dwyer. Before we get started, do a minute to introduce ourselves. My name is Liz Walsh. I am the manager of curriculum and instruction at Code Savvy. I have my email as well as a link to my LinkedIn. We'll share this presentation with you later on. Before I was in this position, I was an elementary educator and had the privilege of working with Katie for several years. And I'm excited that we've been able to continue to work as we are now. But I'll pass it to you, Katie, to introduce yourself.
Great. Hello, everyone. My name is Katie Dwyer. I am excited to be here. My current position is Curriculum Integration Coordinator at Zanewood Elementary School STEAM, which is part of the Osseo Area School District. Prior to this position, which I've been in for a couple of years, I was in the classroom for over 20 years, anywhere from pre-K all the way up until a specialist where I did K through 5. And I taught a science and engineering curriculum, which brought me to how I got involved in CS. There was a computer science module for each one of the grade levels, and I had never had any experience with computer science. So I became a learner and really just had to learn with my found that I was really passionate about this. So I'm really excited to be here today and talk with you a little bit about how we have, Liz and I have worked together to integrate computer science at Zanewood. Liz, I think you're still muted.
Oh my goodness, thank you. I was giving such a passionate speech too. Essentially, we've got our welcome and introductions. We're going to do a brief introduction to what is computer science to kind of level set us today, talk about integrating computer science in elementary school, give you an opportunity to brainstorm and plan, and then we'll move into our next steps. By the end of this session, you'll be able to define computer science integration, identify the importance of integrating computer science into the content area classroom, and explore an integrated curriculum resource. And finally, begin brainstorming how to integrate computer science into your classroom. So in the chat or unmute, what do you think of when you think of computer science? I see coding, robots, all the CT skills being applied. Awesome answer. Computational thinking skills, robotics and coding. Awesome. So what we really want to highlight, and before we dive into talking about integrating computer science in our classroom, it's really important to be sure that we have a common definition of what computer science is. So computer science is the study of computers and how they work. It's learning about how to create programs that make computers do things. Computer scientists develop new technologies like apps and websites and figure out ways to solve problems using computers. They also make sure that computers are safe and secure. This field helps us better understand the use of technology. Looking at this screen, you'll notice that the field of computer science is a huge field, and it's made up of many different subfields and specializations. What are some of the subfields here that you've heard before? Drop that in the chat. I see software development, technology. I know that game development is one that's really popular with students. What I really want to do here is just emphasize here that many of us believe that computer science is, or many people believe that computer science and coding are one and the same. However, computer science is more than just coding, and coding is just a skill that is used in this field. You'll see this further reflected on the visual on the screen, and notice that programming or coding is just one small part of computer science. You'll also notice a new part of this visual, which is this computational thinking here. Computational thinking serves as a foundational skill within computer science, and it's a problem-solving approach used by humans to break down problems into smaller steps, find patterns, and create clear instructions that in turn we then can give to a computer. The one thing I really like about computational thinking is that it doesn't exclusively live in computer science, but is also a problem-solving approach that's central to computer science, but can be applied more broadly to problem-solving and learning in any discipline. So for example, collaboration is a computational thinking, debugging, algorithms, sequencing, these are all things in computational thinking. With that, I'm going to pass it over to Katie.
Awesome. Thank you, Liz. So knowing now how important it is to expose students to CS and other tech opportunities during the school day and throughout their school career, let's just reflect on CS. And so thinking about computer science in your school that you're currently at, if you're at a school or a school that might be near to where you are working, thinking about how computer science shows up in your district or across the state. So think about that. Feel free to unmute, or you can drop in the chat ways that you have seen CS reflected in your school, your district, or across your state. Thank you, Jean. A lot of Scratch programming, but not a lot of other parts of CS. And that's pretty common to see schools or districts take a tool and try to integrate that. That is a very common thing that we do see. Teaching specific lessons during library time, absolutely. Some things I've seen in the schools I've worked at, the hour of code, things like that are integrated into the school day. Only summer programs with some robotics. Thanks, Christy. We're starting to include it in our district, but we will start with unplugged activities and then BBOTs. Awesome entry path. Wonderful. Specialists, that's how I started. I was a specialist when CS was introduced at the school that I was working at. Lori, good to see you, Lori. Microbits, coding in Scratch, hour of code. Lori works at another elementary school in Osseo, also another magnet school, which is the type of school that I work at. A lot of game playing or downtime exploration, but not a lot of direct instruction, absolutely. Code.org, another great resource that's available and accessible, robotics. Kathy, great. Scaffolded across pre-K to 5. Love hearing that. That's amazing. Excellent. Thank you all for your engagement with that. So kind of piggybacking off of that, thinking about how our students experience CS in schools, in the district, in the state. I just wanted to have you take a look at some of these images. And as you're digesting these images, be thinking about any potential issues that you see with the images that are presented. The images represent CS opportunities. So thinking about that, what are some issues that you see here? Oh, awesome. We have some additional comments in the chat. Great, Emily, a CS specialist, K5, that's awesome. Scratch Junior and Scratch, BlueBots, Ozobots, wonderful. Lego Spike Prime. Another comment, we created a curriculum for primary education, trained teachers and created unplugged resources, wonderful. Wonderful. And robots for integration. Excellent. So some of the issues with the opportunities that are currently on the screen, the opportunities are optional, meaning that some kids may opt out thinking that that's not for them or that they're not capable of doing those particular things. Additionally, extra money, time, and resources to participate in these different optional opportunities. And excellent. A lot of them are outside of school. Limits enrollment of students who have access to transportation after school, things that are outside of the current school day. Those are all excellent, and really what the focus and the takeaway here is that not all students are being provided with access in our state. Those of you that may have attended Andrea's session before this one may have heard that Minnesota is last in the country for computer science. And so we really have a lot of work to do with regards to providing access and removing barriers for our students in our state. And another comment that just came in the chat, the need to have every student sign up to have an account to also use the resource. Absolutely, that can be a barrier for students if they do not have access to an account to do that. Wonderful. And so now I'm just going to take a little bit of time to describe how I've started to try to introduce a CS pathway at Zanewood. So as I mentioned before, I started at Zanewood a couple of years ago, having spent the most of my time in education in the classroom teaching. And then having to go into this role, my goal here was to really not forget what it's like to be a classroom teacher. And how do I make CS as accessible and engaging as possible for both students and staff? And so the one thing that I really tried to focus on with the educator focused programming is not to add one more thing to an already overflowing plate. Having been a classroom teacher for as long as I was, the thing that used to really irritate me more than anything else was to go to a PD or to have some sort of new initiative rolled out, but nothing was ever taken off of my plate. And so everything sounded great and I wanted to try these new things, but it's like, when am I going to have the time to do that? What are you going to take off my plate in order for me to add this onto my plate? And so thinking about that, I wanted to focus on developing educator content and professional opportunities so that educators didn't feel like this was one more ask. The way that I decided to approach this is really having this CS pathway develop organically. So first starting with offering optional PD for teachers to opt in. So no one's forced to come to this PD. These PDs were before school. Educators were compensated for their time. If you're going to come outside of your contract time, you should be paid for that. Your time is worth it. And so that was really the focus initially. Some of the ways that Liz came down and she did some unplugged activities with our staff. We did a CS playground, so staff got to go around and experience the different tools that we have, such as B-bots and Ozobots, microbits, and really get to take on the role of a learner and making sure that they felt comfortable with the tools. Another thing that we really focused on was building some computer science vocabulary that was scaffolded kindergarten through 5th grade. And that was an ask by a group of teachers that at the school were very interested in rolling this out, but wanted some more structure. And so Liz and I worked together to come up with computer science vocabulary K through 5, with the understanding that some of that vocabulary might repeat, but teachers really had an understanding of how to enter in to introducing the vocabulary, and they also got to see the process, what was going to happen as their students left their grade level and moved on to the next grade level. We also had a heavy emphasis on the component of computational thinking and just how much of computational thinking is really evident in multiple content areas throughout the school day. For example, we had a teacher who went to one of the professional development opportunities who then decided to change the way that she did her morning routine with her students. So instead of students coming in and just following the routine, she created a morning algorithm, and that morning algorithm had different images right up on the screen, and she called it the morning algorithm. So she's able to really just introduce a concept into something that she already did. So when we think about the educator focus, I also wanted to make sure that I was considering what was the student experiencing and what will they experience on their end. So another community partner that we do work with at Zanewood is Create Minneapolis. Create Minneapolis is a nonprofit, and their focus is really providing programming to students pre-K through 5th grade. For our particular school, they do programs for older scholars as well, but they really focus on the design process and then also introducing all of our students to coding. And how this has happened is we have been able to rotate classes through during the school day. The lessons have been led by Create Minneapolis staff. I think it's really important that we entered this way so as to not overwhelm teachers who are already overwhelmed trying to learn a new science curriculum, potentially a new literacy curriculum. We might have a teacher that's brand new to education. And so what they do is they are in the classroom with the Create staff. We also have a talent development teacher that helps out as well. And what Create has done this year is they have created 12 lessons per grade level that can be replicated now moving forward. And so not only did the educator get some professional development just by being in the class with their scholars, they were able to really engage in the content and while somebody else was doing the teaching. And this was a really nice way for teachers not to feel overwhelmed by having to introduce computer science, which could be new for some of our educators. And in addition to that, we took the Code Savvy Bite-Sized Challenge curriculum, and we now have introduced that to all of our 5th graders. And so this works. I am actually helping with this right now, and we have a technology ESP who assists, as well as Create Minneapolis. And so what Bite-Sized Challenge is using the microbit. There are 16 lessons which focus on design thinking and then physical computing. So far, we have all but I would say maybe 10 of our 5th grade students who have opted into this challenge. When we first rolled this out 2 years ago, a month of me being there, I decided, oh, let's just try this. I only had 5 students. And so now it has expanded and we have one 5th grade class. I think almost all of the students are engaged in this. And so moving forward, we're really going to focus on targeting our 5th grade scholars with this opportunity with the hope that it will just become a course, a computer science course that our scholars will be taking. And so thinking about our school year moving forward, so going into next year, the focus will be introducing that CS vocabulary that I mentioned that's scaffolded kindergarten through 5th grade. And the hope and the ask is going to be for educators to begin to integrate, if they haven't already, that CS vocabulary and concepts into their existing lessons. So not an additional lesson, but existing lessons. So for example, when you think about scholars in math learning about different algorithms, that's another way that we can just bring in that concept into something that they're already learning in math. We're going to continue with our partnership with Create Minneapolis. We are going to have Create Minneapolis kind of do a slow release of responsibility. So having our talent development teacher and general education teacher begin to take on those 12 lessons with Create Minneapolis still being there as a support. But that slow release of responsibility now that educators have seen the lessons again, with the hope that eventually they'll be able to take those on. We're going to continue with the bite-sized challenge in 5th grade, as I mentioned. And I actually would like to move that to the beginning of the school year. Much of the bite-sized challenge curriculum has wonderful social emotional components to the beginning, team building at the beginning. And I think that would be a nice entryway for our fifth graders as they begin their school year. And then finally, the fourth component that we're hoping to introduce next school year is CS integrated curriculum. And what I mean by that is all educators are going to teach at least one CS and science lesson that's aligned to one of their already existing science units. So Liz and I have been working this year together. We have taken one lesson from Amplify Science that teachers already have to teach. We've kind of unpacked that lesson. And what we've done is we've integrated the vocabulary into the lesson. We've integrated a CS concept into the lesson using those CS benchmarks provided by the state of Minnesota. And then also trying to tie in some math as well. And so the end goal here is during workshop week or beginning of the year, I will have created a resource for teachers where they can go in. They can see exactly what lesson it is. The slide decks will already be done. And when they get to that lesson in their Amplify, instead of, so in place of what the Amplify might be telling them to do, which could be a worksheet, they're going to get to do this integrated CS lesson. So once again, thinking about a teacher, how much they have on their plate, this is not in addition to, this is instead of, and it's actually more bang for your buck, so to speak. So you're getting one lesson. That one lesson is going to have your CS, it's going to have your science, it's going to have some math, and it's already a lesson that is from our district mandated curriculum. And so thinking about CS integrated curriculum goals, making sure that we support educators in bringing computer science to their classrooms and really having this become a school-wide initiative. One of my jobs in my role right now is to solicit feedback from families regarding our magnet program. And one thing that I heard loud and clear from families is that they were really wanting more technology and CS experiences for their children. That was loud and clear. And so the way that I really approach this and then also explain this to teachers is that this is what families are asking for, and rightfully so. And so moving forward, making sure that we have new CS opportunities that are integrated into existing subject areas to provide the best support for educators as possible. So again, not asking them to do one additional thing, but rather to look at the existing curriculum that they have, the existing standards that they're expected to teach, and providing opportunities for them to enter CS into those different areas. All of the new CS standards need to have an alignment to Minnesota State academic standards. And so really making sure that we're being very intentional and mindful of those Minnesota standards. And then all new CS opportunities have to align to our district mandated curriculum. We have a huge district in Osseo. We have pacing guides available for our teachers that they're expected to follow. And so by tying in this CS into what they're already expected to be doing, it's not going to feel, hopefully, as overwhelming for teachers as asking them to do one additional thing, which they'd view as being in a silo rather than part of their everyday work. And so this graphic is great here. Basically, what we are for is that we have lessons that prioritize the active creation to enhance both content as well as the CS skills versus lessons that might be more of the student just consuming the CS and not being actively involved. So we really want to make sure that lessons have students learning how to create with technology and aware of technology impacts. And so when we think about students not just being consumers of tech and CS, but they're actively involved. That's really more of a holistic approach to education, which we know works really well for students developmentally. And not only does that foster creativity, but it really helps students develop a deeper understanding of technology and the impact that technology has on society. When we have hands-on projects, it's going to really require the students to start to develop those 21st century skills that we know are so important, regardless of what they decide to do after school. Critical thinking, collaboration, innovation, creativity, all of those 21st century skills that are very important. And really the why behind this is that we really want students to be proficient users of technology, but also responsible creators. We are in a digital world. It's not going anywhere. And so tech and CS really is here to stay. And so we really want to focus on involving our students in a way that when they leave school, they're able to contribute positively to our digital world and add to the digital landscape that already exists.
Awesome. So we're going to transition a little bit and talk a little bit more about the process that Katie and I went through when creating these integrated CS lessons, because it can be really overwhelming to think about how am I going to take these CS skills and integrate them in a way that's really meaningful across subjects. So what I'm going to do in the next couple minutes or so is highlight the process I went through with Katie and then give you an opportunity to try out that process yourself. And I'm going to focus on the 3rd grade lesson that we created. I always like to start off with the question of like, where do we want to integrate computer science into? Just to like narrow the focus and to make it a little less overwhelming. And based on our conversations, Katie and I felt that integrating computer science into the existing science curriculum was a really effective entry point for Zanewood and Zanewood educators. Next, I moved into the Minnesota academic standards and didn't even think about computer science. So Katie and I looked through the Amplify Science curriculum and then looked at the Minnesota state standards, because as Minnesota educators will know, oftentimes the district mandated curriculum doesn't hit all of those Minnesota science standards. So there's already places that you have to fulfill or add to your curriculum. So we wanted to make sure we were hitting that space. One thing that's really nice that's been released from the Department of Education are they've already identified those benchmarks where computer science can be integrated into. So far, they have those identified for science, art, and language arts, knowing that with the revisions of the standards in the coming years, ultimately, they'll have identified benchmarks in all subject areas across Minnesota. So that's how we came up with the Minnesota Science Standard that we were going to focus on, which is having students organize and electronically present collected data to identify and describe patterns in the amount of daylight in different times of the year. Being elementary educators, we both were like, there's more standards beyond this science standard that we could integrate into this lesson to support educators in hitting more than just the science lesson. So Katie and I spent some time looking through the math standard and really felt that having students also use an analog thermometer and collect data on temperature throughout a 30-day period, as well as the amount of daylight, naturally fit together in this space. So that's kind of where we started. Then we went to the CSTA standards. And if you don't know, CSTA is a national nonprofit focused on computer science for students and educators. And the CSTA standards are a set of learning objectives designed to provide the foundation for a complete computer science curriculum and its implementation at the K-12 level. So what we really use these standards for is we know that we wanted students to collect data, and ultimately they're going to be creating something with technology that presents this data. So what we went through is we went through those 3rd through 5th grade standards and found these 2 CSTA standards. The first one being organize and present collected data visually to highlight relationships and support a claim. That aligns very closely with that first Minnesota Science Standard. And then We wanted students to create a program that uses variables to store and modify data. I'll get more into what that standard means in a minute. So after we've done our brainstorming and planning, you'll notice that we haven't picked a tool, we haven't picked a platform. We're really just thinking about what do we want students to know by the end of this experience. And we haven't focused on bringing in some tech or unplugged, which brings me to the next piece is after you've started that brainstorming, it really is important to start thinking about what tool or what are you going to integrate to support students' learning and understandings. So what we did is we focused on, are we going to integrate a CS tool or platform, or are we going to use unplugged activities to support students in meeting these standards? As you all know, there are a variety of tools and platforms available to elementary educators to teach programming, physical computing, and so much more, and many of these are free. Some of these tools include like Microbit, Sphero, Makey, Scratch, and a long list of others. But I want to emphasize there are other ways to teach computer science without these tools, and these lessons and activities are called unplugged activities, and they refer to computer science or coding activities that do not require the use of computers or digital devices. Oftentimes, I know for myself, when I was teaching computer science at first, I thought the only way to teach it was to break out Scratch or take out the Makeys. But you can really teach effective computer science completely unplugged. And these unplugged activities are just as integral to creating a computer science curriculum and pathway, especially when we're wanting to prioritize like the active creation and understanding of computers and how they work. Oftentimes it's way more effective to teach these complex concepts to students without the tool. So they're not having to learn how to use Scratch and understanding what algorithms and conditionals are. They're just learning that concept in isolation and then bringing in the tool. For this particular project, I created lessons for Zanewood K5, and throughout, by the end, we were about 50-50, where 50% of the lessons were completely unplugged with no tool or platform being integrated into the lesson, and the other 50% used a tool. I just really wanted to highlight that you don't have to become proficient in a tool or a platform to start integrating computer science effectively into your classroom. But for this particular lesson, we decided that we wanted to integrate Scratch, specifically because of that Minnesota state standard where they're creating or using an electronic device or visualization, and we thought of Scratch. If you don't know, Scratch is a block programming language that's for young learners and new programmers where they can create their own games, their own animations, and so forth. So for this lesson, we wanted to create a program where students would learn how to collect data through Scratch. So ultimately, by the end of the lesson, they'll have created a program that collects and stores their temperature and daylight data over 30 days. So what I want to do is I want to give you a moment to practice and work through that brainstorming process and think about where you might be integrating computer science. In a moment, I will drop a document similar to the one that I use when I created these lessons for Zanewood. Your job in this about 5 minutes or so is to think about your classroom and your environment and how you might want to try integrating computer science. You probably won't get a full flourished plan in the time we have here, but it's really just an opportunity and a resource to start thinking about where you can start integrating computer science into your classroom. I also want to highlight, please unmute or use the chat if you have any questions or if you want ideas or you want to work together. This is a great collaborative learning environment for us all. Here is that link to the planning document. Oh my goodness, I sent it to the waiting room participants. They wouldn't know what that was. Okay, now you all should have access to it. But yes, feel free to unmute if you have any questions, but I'll start this timer. All right, I know 5 minutes was definitely not enough time to probably get through the first two parts of that planning document. But I do want to open the floor up to anyone that wants to share what they were working on or thinking about through that brainstorming process. And maybe we can brainstorm together or support. All right, I did my 30 seconds of wait time, felt like 3 hours. But if you have any questions or you do want to share, feel free in the last 9 minutes we have together to drop it into the chat. But let's continue on. One thing I did want to leave you with is you're probably like, okay, Liz, I worked through this brainstorming process. I've identified the standard. And now I'm like, so what's next? And I want to point you to a strategy that I use a lot when I'm creating these specifically programming lessons and how I structure the lesson to support learners. And that's really through the PRIM model. I reference it a lot. If you've been in meetings with me before, you've probably heard me say it a million times. But the PRIM model is an approach that can help teachers structure their programming lessons. And it's PRIM stands for predict, run, investigate, modify, and make, referencing the different stages of a lesson or a series of lessons. Some lessons you might get through the entire PRIM. So other lessons you might only get through PRI. But it's a really great strategy and support and structure for creating these lessons. Predict really focuses on having students look and discover the function of the program. So if we were doing this or this slide here, we would, without the answers on the slide, have students look at that block of code and predict what they think it's going to do once it's run. Then they would have access to the code. You'd share the link to the starter project and they would run it and test it against their predictions, see if they were right, see if anything surprised them. And then investigate is where you provide them with short prompts or questions to have them really look into the code and investigate how it works and how different changes could be made to it, which then goes right into modify. So our different exercises where students are starting to modify the program and make it their own. And then finally, make is where they would create a program that follows a similar structure, but they'd be starting from scratch. What I really like about it is it really moves throughout the process the ownership of the code onto students. So kind of eliminates some of that fear when learning something new, when you're working in someone else's code or program than in your own. You can learn more about the PRIM model from the National Center for Computing Education, and I'll drop this link right now. They have a bunch of CS instructional strategies for educators, so I encourage you, if you have the chance, to check it out. But this link right here is a blog post that just talks a little bit more about PRIM and how to use it in your classroom. But they have a bunch more. So definitely take some time to dive in there when you have the chance. I do want to highlight some next steps and opportunities with Code Savvy. Later this summer, we're going to be offering a comprehensive educator scratch camp that's going to be beginner skills, intermediate skills, advanced skills. So by the end, you'll walk away pretty confident in teaching with Scratch. Then I also want to plug our Code Savvy Educator cohort. Applications are open for the next year. But essentially, this is a year-long learning opportunity for educators, K-12, regardless of your background in computer science, to learn more about the field of computer science and different instructional strategies and resources to bring it to your classroom, school, or district. So I'll drop those links here right now. And before okay. Did you have some
Just a plug for the Code Savvy Educator cohort. I took that, gosh, during the pandemic, I think, when I was trying and plodding along with the computer science module, not having any experience, having taught anything like that before. It was a huge support to me. I cannot thank Code Savvy enough for that opportunity. There's also opportunities, I believe you still do the graduate credit that can be obtained. And so I was actually able to take that as a course, which helped me move over a lane for my salary, which was a unintended positive consequence of joining that cohort. So I can't speak more highly of that cohort. So if you are interested or you have people that you work with, colleagues in your building who are interested, really encourage them to join. It's very accessible for educators.
I should have you in our next session, Katie. If you want to learn more, we're going to do a panel discussion. We're going to talk to some active or current cohort members about their experience. So that's what's happening next. And then the last thing is both Katie and I want you to connect with us if you have any questions or if you want to collaborate or work together. You can connect with us on through email or on LinkedIn. This slide deck will be available to you all after the summit, so don't worry about catching any of these links. You'll have access to them once that's shared out. I also wanted to provide you with an interest form. If you are interested, if your school or you're interested in the work that similar to what Katie and I did together, you can fill out this form and we'll connect with you on how we can best support your school and district in bringing more computer science opportunities there.